In this session, we are going to talk about what is LS Dyna, how the evolution of LS Dyna happened, and its application in the different fields. If I have to define the LS Dyna in single sentence, then that would be LS Dyna is a nonlinear transient dynamic solver. Of course, LS Dyna can do the different type of analysis, but in organization, LS Dyna is mostly used for the nonlinear transient dynamic analysis. So in short, you can also say LS Dyna is an explicit solver. In the previous sessions, we have already seen the meaning of nonlinear, transient, dynamic and the explicit word. So let us not spend time over here and let us move on to the evolution of Dyna to its current name as LS Dyna. The very first version of LS Dyna was Dyna 2D. Though Dyna 2D was able to do the stress analysis, but there were so many things which were needed improvement. These things include proper element formulation, contact definitions, hourglassing and the material models. To overcome this drawback, another version of Dyna known as Dyna 3D was released by the John Hallquist at LLNL. Lots of new additions and improvements were made in the Dyna 3D. These improvements include better contact treatment, simple material model and the simple simulation capabilities. In addition to that, there were also new features which were added in terms of element for the beam, shell and the discrete element. In Dyna 3D, there were also addition for the optional hourglass treatment, single surface contact, different metal forming technique and the capability to do the dynamic relaxation problem. And finally, in 1989, the first version of LS Dyna is released under LSTC. LS Dyna has improvements including effective element formulation, composite modeling, spot weld modeling and the energy calculation. If you want to get more idea about the evolution of LS Dyna, you can pause the video and check the capabilities of different versions of LS Dyna. In addition to this, let us move on and see how year-wise LS Dyna has improved. I know there are a lot of things on your screen, but again you can pause the video and year-wise you can check how the releases have happened. In addition to that, if you want to get more idea about the particular release, you can go on to the dynasupport.com/release notes. Over there you will find the more detailed explanation about the capabilities of each of the version. I will just quickly go over the important points in this slide. So as we have mentioned, in 1989 the first version of LS Dyna was developed under LSTC, that is Livermore Software Technology Corporation. Prior to that, the first version of Dyna 3D was released as a public software by John Hallquist at LLNL, that is Lawrence Livermore National Laboratory. After the LS Dyna release in 1989, there were lot of improvements which were needed. One of the best version of LS Dyna after its release is version 970. There are still few organizations which uses the version 970. After version 970, there were new addition as well as the improvement made in the successive years. In the year 2014, LSTC changed the way of naming the releases. So from the year 2014, we have the releases started with the letter R. For example, in the year 2014, another version of LS Dyna was released under the release of R7.1.2. So this was again important milestone and many organizations still uses the R7 version. The latest version of LS Dyna is R13.1.0 which was released in the 2022. Of course, as the year comes, there will be new improvements and the new versions of LS Dyna. So I hope you got the overall idea about the evolution of LS Dyna. Now let us move on and see the typical application of LS Dyna. As I usually say, for any solver the applications are unlimited. You can just close your eyes and imagine the domain. In that domain, the LS Dyna or any solver can be used. In the successive slide, I have segregated the most popular domain in which LS Dyna use. First domain that we have is the automotive domain. So if you heard of frontal crash test, airbag simulation, side impact, all these things can be done in the LS Dyna. In addition to this, there are other automotive applications which I have mentioned in the slide. You can go over this test and if you want, you can search through the internet in order to get the more detail on this test. Let us move on to the different domain. So here we will talk about the metal forming. In case of metal forming also, the typical analysis such as hot stamping, deep drawing, roll forming and other metal forming processes such as line die simulation, progressive die simulation, metal clinching, all those things can be done in the LS Dyna. Same goes with the aerospace industry also. In the aerospace, you might have heard of the simulations such as bird strike, water landing, or the landing gear simulations. These simulations can be performed in the LS Dyna. In addition to this, other aerospace applications such as blade containment, fuselage impact, seat anchorage, all those things again can be done in the LS Dyna. Let us move and see the LS Dyna application in the civil engineering. So analysis such as dam breakage, different type of structural analysis, blast simulation can be done in the LS Dyna. Since LS Dyna is one of the best explicit solver out there, here the application of LS Dyna in defense sector is immeasurable. So in the defense industry, we can perform the analysis such as projectile penetration, railgun analysis, and warhead design. In addition to that, of course, the explosion and shockwave modeling can be done in the LS Dyna. One of the most popular example of any explicit code including LS Dyna is the consumer domain. So in case of consumer domain, we can do the different drop test such as packaging drop test, fuel tank drop test, or any appliance drop test for that matter. In addition to the domains that I have just described, LS Dyna can be used in the oil and gas industry, medical industry, manufacturing industry, multi-physics analysis where different domains are involved, CFD application and electromagnetic. So I hope you got the overall idea about the applications of LS Dyna in different fields.